Thank you. Today, I'm going to present a detailed mapping of lava flows and gravity system-like swarms of the Mboko Mons region along Paracasma southeast from Atla Regio, Venus. Next slide, please. The outline and adopts of this presentation as follows. I will start with introduction, study area, and then the results of dike swarms and gravity system and lava flows of Mboko Mons region, and finally future work because our work are in progress. Next, please. The question is, where is Mboko Mons? Our study area is located southeast from Atla Regio along Paracasma, which includes multiple coronae along it. To explore this relationship between rift system and coronae Mons more fully, we have selected the region along Paracasma for detailed mapping. The sketch map identifying the major features of the Parga region, including Atla and Temis Regio. The box shows Mboko Mons location along Paracasma. Next, please. The star image shows the location of the studied volcano, which is surrounded by multiple magmatic centers, like among Ripa and three unnamed corona. The whole area is crossed by a huge graben system named Penthesilea fossa. This region is associated with numerous extensional graben of a range of trend and other extensional features that are likely normal faults. So let's start our results with the graben system like swarm of this region. Next, please. Next. In this region, we have mapped over than 11,000 lineaments that have been grouped into different sets according to their geometric pattern, radial, circumferential, or linear. Many of these are radially and circumferentially associated to their specific magmatic center. For further interpretation, we have taken detailed mapping of figure A and generalized the distribution in figure B. Next. From the summits of the studied volcano, we can say that Mboko Mons is associated with an unusual pattern of multiple fine subswarms, which allow us to identify four magmatic centers as potential source of all these subswarms. This area is characterized by radial fractured material and has a rather high radar brightness due to intensive presence of gravens. All these graben and their magmatic center are associated with normal faults which are located in rift zone segments. These radiating systems are characterized by straight, long, and narrow graben, which radiate from each center. Many of these dikes tend to be wider close to the center and narrower when they are located away from it. In some cases, this young radial fracturing could be a source of some low-grade lava flows which emerge at the same elevation, indicating a possible connection with underlying magma chamber. Next, please. Very close to these multiple centers, more precisely to the west, our mapping shows a very prominent arc system of grabens, which are located 27 to 100 kilometers to the west. These grabens are bent away from the multiple centers discussed before, and they represent and they form the lava flow associated and represents without doubt the latest phase of the Mons evolution. This is supported by the location of these grabens on the prominent slope of the lava, which confirms that these grabens were found by the lateral spreading of the flows. North of this arcuate feature, we have mapped two linear sets of different trends. They may belong to a regional swarm that could be 100 kilometers away from the center. So the green system is crossed by the red swarms, which seem to be converging to south, which could mark another cryptic center in the south. Next, please. As shown before, the studied region includes the multiple magmatic center. One of the huge magmatic centers in this region we mentioned among corona, which is characterized by complex pattern of arcuate, circumferential, and radiating sets. Among corona states adjacently to a Velida linea section of the Parga rift system. This corona is characterized by dense graben, a rough lava flows, single annular low topography. Some of the lines belonging to this corona are partially covered by the flows that were fed from corona to the north. The second corona is located northeast of Penthesilea fossa. This small unnamed corona is characterized by concentric extensional graben interpreted to have been fed by dikes and other compression structure like ring ridges. This small corona contains shield cluster and surrounded by polygonal fracture. Some of the dikes belonging to this small center are partially covered by the flows that were fed from Mboko Mons. So the second part of our presentation is about the lava flows of Mboko Mons, current mapping and geological setting. Next, please. Next. Our mapping here provides a more detailed map of this edifice and its context, permitting the construction of its geological history. The mapped units here were distinguished and identified based on their radar properties, topography, and morphology. So to increase clarity, these areas have been divided into several sectors. Next, please. This map shows a voluminous volcanism associated. The lava flow radially downslope away from the multiple central locations of the summit, but some of these flows appear to emanate from large specific ravines on flanks of the main edifice. These colors indicate different generational flows mapped on the basis of embayments and cross-cutting relationship. Next. Among the sectors that we are going to discuss is the northeastern, which is characterized by 9 geological units that they were fed from different sources and are associated to different magmatic events. For this reason, we have divided this main sector into subsectors. The red line shows the boundary between them. In the first subsector, the package of flows is heavily affected by linear fraction of east-west direction, which is less pronounced in the second subsector. The flows in this later flow and originate radially from a center which is topographically high, as was indicated by control lines. The arrows show the flow direction which extends all the regional plane to the northeast. Next. In the eastern sector, here we have identified 5 geological units. The most pervasive unit, linear trend lobby flow with various widths and radar backscatter. All the flows in this sector were fed from a center which is located above this arcuate feature, except the bright flows, which is mapped in Greenwich color, which appear to emanate from dikes of east-west direction. Evidence that the emplacements of these flows and the linear dikes were simultaneous. The same unit is covered and surrounded by the later flow units of different ages fed from their main sources. Next, please. The following sector is distinguished by elongated flows. All the flows here are greatly affected by 2 families of dikes. These flows here are going downhill. 5 units were mapped so far. The oldest unit is characterized by has radar bright, mapped with this dark color and has ring ridges. The youngest units mapped with light color extend and cover some lineaments belonging to the neighbor center to the northwest. Regarding the source of all of these flows here, according to topography, we can say that these flows were fed from the center, which is located in the bottom, as was shown that this red star. The origin of this source could be an underlying of a magma reservoir. Next, please. In the western sector, the flows change their morphology from east to west. This could be linked to the nature of topography, which become less steep and influence the relief with shallow slope. The source of these flows is less ambiguous because it's partially covered by the radial dikes in radial fracture associated with inferred dikes activity of Mokomons. Some of the mapped material is represented as a flow with finger, which seems to be the oldest material. The youngest volcanism shows the dominance of dark, widespread, and smooth flows. Next, please. In our future work, we will establish the chronology and develop insight into the genetic relationship of Mbokomons and the other coronae, Ripa, Among, and 3 unnamed coronae. We will distinguish and assess the relationship between dike-induced graben and fracture of tectonic origin. We will define the origin of central cycle.
We seem to have lost audio.
Naima, are you there?
If we don't hear back from her in about 10 seconds, I guess. Well, first of all, we can take opportunity for some applause for this amazing talk.
So I can finish her conclusion on future work if you think.
Go ahead. Yeah, sure.
Okay, so her future work is also define the origin of central circular depression that drops the 400 meter below the height of the rim of Bokumu Mons. And lastly, to compare the graben and the flow history of Bokumu Mons with the potential terrestrial analogs.
All right, thanks.
Thank you. So I think we lost her, so we can move to the
Yeah,
next.
I think we're going to move. So I'm going to transition back into the moderator mode. Thank you,
Okay.
Hafida. That was great.
Thank you.